Okay, guys, I think I'll start now. So, hi everyone. My name is Ddos Shapira. I'm a product manager at Capsular, and I'd like to talk today about a little bit about application delivery from the cloud. So, what's application delivery? I looked it up at Wikipedia, and it's actually a bunch of different like a grocery list of different items. But I think that the common thing to all parts of application delivery is probably the following values, which are security, performance, and availability, which are built up from many different items. So how do you deliver application nowadays, or in the past? Probably you have this pile of appliances in your rack, delivering all kind of values, of components, starting from security, whether it's a web application firewall, a Ddos mitigation appliance, load balancers, two-factor authentication services, caching servers, whatever. The outcome of that is probably something that looks like that. And we are starting to see, as for many other aspects of information technology today we see a slow move towards the cloud. So probably many of the apps of people sitting here in this room are currently hosted in some kind of cloud platforms, whether they are Amazon, Windows Azure, Rackspace, etc. So how can you take moving your applications to the cloud also poses difficulties. For example, how do you take all the pile of appliances that I just showed you and move them to the cloud together with your applications? Let me go back for a minute. One option would probably be just building new instances and installing virtual versions of your appliances on those instances. For example, you can purchase another instance and install a WAF on this instance, or a load balancer, or whatever. This would be a good solution, but it's probably pretty naive, because it will not allow you to actually leverage the values of the cloud towards your setup. You will just copy what you had on premises and place it in the cloud. It's probably not the best thing to do. What's the other option? Moving everything to the cloud in a smarter way that leverages the cloud better and the values that the cloud brings with it. So I'm going to use Capsular, the Capsular service as an example to how this can be done. There are other services that do this, but A, I happen to know the Capsular service a little better than other services, and B, I think that Capsular is one of the service providers that where it was amongst the few that actually captured the value of the cloud for application delivery. So the cloud can bring you much more than just copying what you had on premises and placing it in the cloud. And I'll give you examples using our service to explain how this can be done. I'm sure that in a couple of years you will see lots and lots of services doing just that. So what do we do in Capsular? Basically, we're trying to solve operational problems around the three pillars that I just mentioned: security, performance, and availability. And we do it directly from the cloud. And you can see other services doing the same as we speak. The services that build our offering are kind of the basic services of application delivery, which are application security, Ddos Protection, CDN and optimization, and load balancing and failover. And I'm going to discuss in a few words the values of the cloud for each of these services. So let's start talking about web application security, because we are basically a security company. That's our DNA, and I think that I can give you some very good examples talking about web application security. So how does the cloud affect the capability to secure applications, to better secure web applications than just an on-premises solution such as a WAF appliance or a similar solution? First of all, there is the element of crowdsourcing. So Capsular sees over 50,000 sites on a daily basis that are being served by Capsular, terabytes of traffic. That's a lot of data. You can look at this data from many angles and many aspects. It depends actually on your viewpoint. And Capsular, as a security company, built a lot of technologies around getting from this big data the information that is relevant to securing applications. So basically, Capsular has a very good and unique visibility into the attack landscape. So when there is a new attack pattern, attack trend on the web, we are the first to see it. We have this unique visibility and unique tools that were built in order to find out and detect very quickly new attack patterns and new attack vectors. The second thing that the cloud allows you to do is to leverage this kind of visibility to get a more holistic solution. So for example, when talking about web application security, you can combine a web application firewall that tries to recognize patterns, known attack patterns, together with IP reputation lists that are being gathered on a regular basis and signature lists that are being collected through sophisticated client classification algorithms. And the combination of the three can give you a much better security solution than just placing an on-premise WAF appliance on your premises and trying to find bits of information within a very large darkness. Here we have a very good visibility, and it allows us to have the most updated reputation lists and the most updated signatures. We used to look at services that provide feeds with IP reputation lists and compare them to our lists, and we found out eventually that the unique visibility that we have produces the most updated reputation lists, and with the least false positives. So we don't have IPs that are not attack IPs anymore on our services. We update them on a regular basis, and we have a very updated lists. Combined with the WAF, you can stop attacks at the front door. You don't have to wait until the attacker actually tries to attack your site or your application in order for the WAF to intervene and stop the attack. Most of the times, like 99% of the times, we can locate the attackers when they just visit your application, because they trigger our IP reputation lists, our signatures. We classify them on the fly using JavaScript injections or other techniques. So it allows us to, most of the time, just stop attacks at the front door without even having the WAF to intervene in most cases. Last but not least, availability. When you have a really smartly constructed cloud, for example, Capsular has around 30 POPs. Traffic can be, the redundancy is enormous. You have redundancy within each data center, redundancy between data centers. The availability is just amazing, much better than having an on-premise solution. Even if you have like a cluster of appliances, it's not the same as having like 30 data centers that are fully redundant with each other. It gives a great value in terms of availability. So that's just a taste of what's unique about application security from the cloud. Now I'd like to talk a little bit about DDoS protection. So I don't know, guys, how many of you have ever been under a DDoS attack or how familiar are you with it. But DDoS is becoming much more common these days. We see lots and lots of web applications under DDoS. The main reason for that is that it has become a business. So you can now just Google, I want to attack someone, I want to DDoS my competitor, and you will get like thousands of sites and services, actually SaaS services that will allow you to do it for like pennies. We see more and more of them, and it's becoming like a plague. And I think that the need for DDoS protection service, or at least DDoS protection plan, is very important for any DevOps guy with an application, especially if the application is mission critical. So if when your application is down, you lose money, you should think about DDoS. I don't want to start talking about DDoS too much. I don't have so much time, but you can catch me later on my office hours, and we can I can explain in more details. Just in a glimpse, we used to separate DDoS into two major categories. One is what we call network or volumetric DDoS. It's just simple floods of packets going at your sites, basically just flooding your pipes so that you are not reachable by your legitimate visitors. The solution for that is mainly just having enough capacity to handle such huge attacks. And when I'm talking about huge attacks, the average attack today is about 10 gigabits per second. On a daily basis, we see attacks that are going up to 100 gigs per second. So this is the amount of capacity you need in order to be able to mitigate a network attack. Please bear in mind that most ISPs will not be able to mitigate such attacks, and will probably take you down if they see that the attack is risking other customers of theirs. The more sophisticated type of attacks that we see today are what we call application or layer 7 attacks. Those attacks are more sophisticated in a sense that they are using bot armies to just impersonate legitimate visitors. And the bots are becoming more and more human-like. It's very difficult to distinguish them from legitimate human visitors. And it calls for very sophisticated client classification algorithms, and lots of times also human intervention of security experts to be able to stop such sophisticated attacks. So what can you do from the cloud in order to stop such attacks? One thing is that you need upstream mitigation. I just talked about it a minute ago. You need lots of capacity. Probably an on-premises solution will not do anything here because your pipes will be full. It doesn't matter. You can place a monstrous appliance in your rack. If your pipe is full and you have, for example, 100 megabits per second connection to the internet, or 1 gig or whatever, and you get a 10 gig attack, nothing will help you unless you block the attack upstream. And upstream is probably before it reaches your ISP. So you need some kind of solution. It can be an always-on solution or an on-demand solution that you can pass traffic through to filter DDoS traffic as high as possible above your ISPs, as upstream as you can. For example, Capsular has an aggregated DDoS mitigation capacity of 700 gigabits per second. That's the kind of numbers that you should be looking at when choosing a solution to mitigate network attacks. Security experts. Most attacks start as just blunt flooding of packets and become more and more sophisticated as the attackers learn the patterns of the protection that you are using. So most of the time they will start with something very simple and very big, and will try to understand how you're protecting your application against DDoS, and then start changing the attack patterns to overcome and be able to infiltrate into the application and take it down. You need to have people at the wheel, real security experts that you can call during an attack if you see that something is going through, so they can react to it, and they should have the tools, which is very important because not all services will enable their experts to have good tools to be able to react in real time to such changing attack patterns. Last thing is what I called rapid reaction. For example, Capsular is using its own proprietary technologies. Everything from hardware to algorithms, everything is custom built from scratch. Many providers are using third-party solutions. You should verify that the solution that you are using is one that is flexible enough to be able to react to, as I said, changing attack patterns or stuff like that, because sometimes it's just people that are turning on an appliance that they bought and placed it in the cloud, and it will not be good enough. So this is also an important thing. Okay, another important aspect of application delivery is, of course, performance and acceleration. I guess you guys, most of you probably know CDNs that bring content closer to your visitors. Capsular is quite unique in a few aspects. One of them is that it serves all the cache from physical memory and not from external storage, which is really lightning fast. But I think that the most interesting thing, and there are a few providers that provide this capability nowadays, and I think that we will see more and more of them in the coming future, is handling dynamic content. CDNs in the past never really addressed the aspect of dynamic content and only handled static content. And with applications becoming more and more dynamic, and with transport becoming more and more, let's say, faster, becoming better and better, connectivity around the world is better, the size of the resources becomes less important, and all the dynamic parts are becoming more important. So I want to talk about HTML files because I think they have a major impact both on the performance as the users see it and on the performance as your application servers feel it. So first of all, page load time. HTML files are a significant part of the page load time and become more and more significant as time goes by and as traffic or transport becomes faster. The second thing is server load. HTML files require your web application servers to work very hard in order to produce them. Go a lot of times to the database, bring data. It's very costly in terms of load. I just added here an example. I took our own site, the Capsular site, and I placed it on two different CDNs. One that is completely static, and our CDN. And you can see here with the static CDN, the HTML part took about 5 seconds to complete, which is a huge part of the total page load time. What we found out in Capsular is that most HTML files are actually static. And when I say static, I mean they don't change over time. They don't change with different users that are requesting them. Some are, but many are not. So Capsular developed algorithms that can, first of all, detect and cache static HTML files. We detect files that are not changing with different users or are not changing with time, and we are caching them, actually caching them. And we never cache real dynamic HTML files. And the impact is just huge. You can see here, instead of 5 seconds, it takes less than 200 milliseconds to deliver the file. Page load time goes way down, and the load on the servers is extremely lower than before. Just think of your home pages. Most of the time, home pages do not change very rapidly, do not change for different users, and you get like tons of requests for the home page. which load the servers very much, caching the home page is a very good solution, and of course many other pages of the application. Last thing that I wanted to talk about is load balancing and failover. It's a very important aspect of application delivery, the availability aspect, keeping the application up. I just wanted to show a few researches that I collected. Downtime costs money, and a lot of money. And in Capsular, as a cloud provider, can improve the availability of sites by load balancing and failovering servers and data centers. And I'll show you in a minute different options that are available there. So you can load balance traffic between servers directly from the cloud. You always needed load balancers on premise to be able to load balance traffic between your servers, especially if you want to do it on layer 7. So if you want to do it on the HTTP request level, you had to do it using F5, Citrix, or whatever load balancer you had on premises. You can now do it from the cloud. Capsular is like a pioneer in this area, but I guess in the following couple of years, we will see more and more services that allow you to do just that, load balance traffic directly from the cloud at layer 7. The capabilities here are enormous. You can failover between data centers. You can globally load balance traffic geographically to different data centers on layer 7. So you can do it at the request level and not just using DNS as most services do today. DNS was not designed to load balance traffic. DNS was designed to do DNS. It has many limitations in terms of load balancing. It has TTLs. So for example, if your primary site goes down and you want your users to go to your secondary site, the TTLs on many of the caching servers on the way will probably block them from doing that for at least 30 minutes or an hour. So I guess DNS load balancing is a good solution, but I think that the future is layer 7 load balancing from the cloud. It has multiple advantages, like I told you about monitoring at layer 7, load balancing at layer 7, and maybe the most important thing is that load balancing as a service is not setup dependent. So you can load balance traffic to your physical servers or cloud setups on Amazon, Rackspace, etc., or hybrid setups. We don't care. We only see IP addresses behind us. We don't care if they are physical servers, virtual servers, whatever, or a combination of both. So this is just a taste of how application delivery from the cloud can give you more values than an on-premises solution. And I think I wanted to show here a short comparison of the two. So on-premises, you have a few distinct values, like the ability to fine-tune things to your own setup. You have some privacy advantages when you have everything on-premises, and of course full control, but the cloud comes up with lots and lots of other advantages. Economical, you are sharing the infrastructure, guys, as opposed to every customer just building his own infrastructure and utilizing just like 5% of it on a regular basis. You can share a huge infrastructure that was purchased by a service provider, and if let's say your application requires most of the time only 5% of the infrastructure you're using, and I don't know, just a few days in a year, you really need the entire capacity of what you're using, shared infrastructure is a very economical thing to do. Crowdsourcing, as I said, the unlimited capacity, and the geographical distribution. So, bottom line, the question we started with is the cloud going to kill traditional application delivery? I think that in the short term, not, because there are still values there, but I think that in the long term, which becomes shorter and shorter as time goes by, I think yes. So first of all, thank you, everybody. I have office hours later today at 5:30. You can ask me questions about any of the services I described, about cloud computing in general, and you can also ask questions now. Okay. Thank you.